Hey there, in this video we're going to walk through conducting an ordinary least squares regression analysis in SPSS. I just want to start off going through some of the resources on Canvas. I have a document here on the steps, how you can conduct a standard, sequential, or stepwise regression in SPSS, and it goes through the pull down menu. In the video, I'm going to go through the standard multiple regression and the sequential or block entry multiple regression. So you can follow along here, and I'll show you in the video too. I'll click on Analyze Regression, move our dependent variable over, and so forth. But so here's where you can find that information, kind of the steps to do it. The example we're going to walk through, if you want to be reading along, is right here. Here's my example output that's been annotated. And so we'll walk through all of this in the video today, but you can read that available on Canvas. And then finally, there's a results section of how you'd write up the analysis we're going to walk through right now. You can see here's my example write-up for both the standard and block entry regression model. So to start off this example, the research scenario we're going to look at is we're going to test one of the theoretical perspectives of C. Robert Pace. He basically argues that it's students' academic and social involvement in college that contributes most to students' growth and development. He basically says that the more engaged, the more involved you are in college and various aspects of your college life will lead to greater knowledge and development and growth in college. And so while there's many manifestations of both social involvement, some researchers argue that it's the non-classroom interactions with faculty that are the most important types of social involvements for students. And these interactions with faculty should contribute to higher levels of learning gains. And that's what we're going to test in this regression analysis. So the dependent variable in our analysis is an overall measure of students' educational gains. Questions on the survey ask students about how much they feel they've made gains in several areas, such as like writing clearly and effectively, learning on your own, acquiring job or work-related skills. We're including a couple like control variables for students' grades and the number of credit hours that they have taken. And then we also have 5 variables kind of operationalizing Pace's concept of both academic and social involvement. And so these are scales measuring a student's quality of effort or their involvement with faculty, a scale representing students' quality of effort or involvement with other student acquaintances, scales measuring students' effort in coursework, their use of the library, and then their efforts in writing. And then basically higher values on each one of these scales indicate higher levels of involvement. So the data set that we're going to use, the multireg.save, is available on Canvas. You can see it right here. You can download the data set and follow along. So for the standard multiple regression, we're going to enter all 7 of these independent variables into the regression analysis at the same time. And so you can follow the steps in that document for conducting a standard multiple regression. And then the block entry regression or sequential regression, we're going to enter our 2 control variables, the total credit hours earned, and then students' academic performance or their grades in the first block. Then we're going to enter our main independent variable of interest, students' quality of effort with faculty in the second block. And then we're going to enter in all the other quality of effort variables in the final block. And so that's what we're going to walk through right now. So I've already opened my data set. So you can see units totals, their total credit hours earned. Here's their indication of their grades, where higher numbers indicate higher grades. And then our different scales measuring quality of effort in their coursework, effort in the library, the effort or interactions with faculty members, with other students, in their writing activities, and then a measure of their perceived general education gains. So to run a standard regression analysis, we go to Analyze, Regression, and we're doing a linear regression model. First thing we do is we bring over our dependent variable over here to the dependent box. So we could drag it over here. And then since this is a standard multiple regression, we're going to include all of our independent variables just in the model at once. So I just highlighted all of them and bringing all of them over into the independence box here. And then we'll click on statistics. If you want confidence intervals for your coefficient estimates, you can click this box here. If you want to get a set of descriptive statistics for the variables you're modeling, click descriptive statistics. If you want to get your partial and semi-partial correlations, you can check this box. And if you want collinearity diagnostics, you can click here as well. We'll click continue and then click OK. And so we get our first box here, whoops, is our descriptive statistics. So, you know, it's basically just the mean, standard deviation, and then sample size. So there's 303 students in this data set. And so our basic descriptive statistics, if we were just to ask for the mean, standard deviation in. We also get the correlations among our variables. It's sometimes nice to kind of peruse the correlation matrix. What you want to see is you want your independent variables to be correlated with your dependent variable, because then they're explaining variation in your outcome. You also don't want your independent variables, though, to be highly correlated among themselves, because what's that saying is, you know, if the independent variables are highly correlated among themselves, then they might be measuring sort of the same thing, or they're eating away the same bit of variation in your outcome. So typically what we like to see are high correlations with the dependent variables, lower correlations among the independent variables. So you can sort of peruse here and see, you know, if we were seeing independent variables or correlations around like 0.8, 0.9, we would want to be worried. This box here just tells you what variables have been entered into the model. You can kind of ignore it. For now, it's just telling you what all variables we entered that are in the model. The model summary here is where we can get basically like our effect size measures for our regression analysis. The R-squared statistic here tells us the proportion of variance explained. It's similar to like eta squared or partial eta squared or omega squared that we calculated in ANOVA designs. The R-squared here and the adjusted R-squared both give you an estimate of the proportion of variance explained in your outcome by the set of independent variables. So we would interpret this as 39.2% of the variation in students' perceived general education gains can be explained by the linear combination of independent variables. So all 7 of those independent variables are explaining around 39% of the variation in general education gains. The adjusted R-squared basically just makes a modification to the R-squared that sort of penalizes the R-squared for the number of predictors that you have in the model. The adjusted R-squared will always be less than or equal to the R-squared value. You'll typically see it recommended when the sample size is small or the number of predictors is large. People prefer the adjusted R-square. A lot of times I just report both of them in the analysis. This is your summary ANOVA table. It's very similar to the summary ANOVA table from the one-way ANOVA. Actually, a lot of it's calculated the exact same way. The sums of squares, regression here would be similar to like the sums of squares between in the one-way. The sums of squares with residual would be the sums of squares within on the one-way. Basically, what you're looking at is the significance level of this F test. And so we can think of this F test as testing one of two hypotheses. One, it's testing whether we're explaining a significant proportion of variance in the dependent variable. So it's essentially testing whether this R-squared value is different than 0 or not. And not surprisingly, it is. So this is this is saying that this R-square that we are explaining a statistically significant proportion of variance in our dependent variable. You could also think of it kind of the way you think of like the omnibus F test in ANOVA as, like some combination of the independent variables are significantly related with the outcome. So, this test is saying that, yes, there is some combination of independent variables that are significantly related with the outcome. Well, which ones it are, we look at the coefficients table here to decide that. You can sort of ignore the regression constant or regression intercept. It's only really meaningful when 0 is meaningful for all of these. So this would be this how you would interpret this as the estimated general education gains for someone who's taken 0 credit hours, has a 0 for grades, a 0 for course learning, a 0 for library activities, a 0 for efforts with faculty, a 0 for efforts with students, and a 0 for writing efforts. So this is basically the estimate, the value of the outcome when all of your independent variables are 0. So unless 0 is meaningful for all of your independent variables, the constant is meaningless. So a lot of times we don't really typically interpret the regression constant. So the next thing I typically look at is this VIF column. It stands for variance inflation factors. And this column really gives you an indication of whether multiclinearity is a problem in your data or not. And multiclinearity refers to the intercorrelation of independent variables. So it's how highly intercorrelated are your independent variables. General rules of thumb that you'll see out there is, the variance inflation factors are less than 5, then you don't really have a problem with multiclinearity. If the variance inflation factors are above 10, it's saying that there's extreme issues, and typically above 5, we're usually concerned that something may be going on. Here, it doesn't seem to be an issue with multiclinearity. All of our variance inflation factors are 2 or lower. So that's good. So then we'll continue on then interpreting the regression coefficients. So then the next thing we would look at is the significance level of this T statistic, of the T test for each of the regression coefficients. So this is saying that the total number of credit hours taken at that college is significantly related with general education gains. So basically controlling for all the other variables in the model, the more credit hours someone has taken, the higher they perceive that they have made gains in their general education abilities. We see here that grades is not significantly related with gains. We see that course learning is. So the more time and effort students put into their to learning in their courses, the greater they perceive that they have made gains in they've made gains in their general education abilities. You can also interpret these unstandardized coefficients, especially when the independent variable and dependent variable have their own like meaningful metrics. You know, this unstandardized coefficient is saying that for every 1 unit increase in course learning, we would expect to see a 0.031 unit increase in perceived general education gains. In our case, it's not really meaningful because perceived general education gains and quality effort in course learning aren't very meaningful metrics. Like, what does a 1 unit increase in quality of effort in course learning actually mean? But when they are a meaningful metric, that's how you can interpret that. All of your unstandardized coefficients, the SPSS labels B, is saying that for a 1 unit increase in the independent variable corresponds to a B unit increase in the outcome. So it would be the same thing here for quality effort in writing. A 1 unit increase in quality effort in writing corresponds to a 0.019 unit increase in general education gains. So I would typically interpret that as, you know, controlling for all the other variables in the model. The more time and effort students put into their writing activities, the more they perceive that they have made gains in their general education. The standardized coefficients sort of give you more of like the strength of relationship between the independent variable and the dependent variable. These are more in like standard deviation units. So this is basically how these are calculated is we convert general education gains or outcome to a z-score, and then we standardize all of our independent variables. And this would be the regression coefficient that we would get from that analysis. So if we converted general education gains, standardized it, converted it to a z-score, converted units total to a z-score, this would then be the regression coefficient. So we could interpret this as a 1 standard deviation increase in the total units taken would correspond to a 1/4 standard deviation increase in general education gains. We could scroll back up here and see what is that. A standard deviation for units total would be about 1 unit. So you can kind of interpret it that way. So a little over, you know, a 1 unit increase in total units taken corresponds to a 0.25 standard deviation increase in general education gains. So same thing here, you know, a 1 standard deviation increase in course learning corresponds to around a 0.27 standard deviation increase in general education gains. You can ignore the linearity diagnostics table. I would use this if I had a problem with multiclinearity is an issue. I would then use this table to kind of diagnose it. We'll talk more about that if you take the Stats 3 course. We go into more detail on that.